And welcome to the same problem that we did before on linear programming. In this problem we will solve the same cost minimization problem. The only thing that is different is that we will do this by simplex method. Simplex method is simply a method that we do mathematically by iterations. This is a rather complicated method if we do it by simply doing mathematics. However, thankfully to Microsoft Excel, it has created a program that is called Solver. So through this Solver program we can solve this problem very easily. So it is good to know the mathematics of this as well. However, this is a simple method where we can solve this kind of problem by solving it through this problem solver. So for this you need to have Solver installed. So I have a MacBook computer. You can go to any of your, if you have a Windows computer, you should go to Excel, and you should go to, let's say in MacBook, I think you should go somewhere around add-ons. So that will be in tools, and in tools Excel add-ins. So you would click Excel add-ins, and you would be able to then add Solver program to this. So that's why I have written here that you must have Solver installed in your computer. Otherwise, if you do not have it installed on your Microsoft Excel, you won't be able to do this problem. Good. So let's go with that. This is the same problem that we did in the graphical approach here in the the cost minimization graphical approach. Now we will do it in the cost minimization by simplex method. So simplex method here, simply we need to do the same thing, write this problem by formulating it here. This is what we did and we talked about before. This is the objective function of the cost, that it takes $20,000 per day to run refinery 1, and x1 is the number of days we will run refinery 1. This is 25,000 is the cost per day for refinery 2, and x2 is the number of days we run refinery 2, and that's equal to the total cost. So these are the three constraints that we need to be able to produce high grade at least 25,000. We can run any combination of these because 400 is produced by the first refinery if we run it for a day, and 300 is the high grade produced by the second refinery if we run it for a day, and that must be at least equal. The sum of this must be, these combination must be equal to 25,000, because that's the demand for the high grade oil that the firm is facing. In the same way for medium and for low grade oil, simultaneous medium and low grade oil, the demand is 27,000 and 30,000 that the firm is facing. Then there is non-negativity constraint. So we talked about all these constraints before as well. Then we simply write the same thing in matrix method. For this one, you do not necessarily need for the simplex method to write this in matrix form. It is not necessary. However, it's still fine if you keep it from the other problem that you did it here. Good. What is the thing that we need to do here? The only thing we need to do here is to create this small table in here. So this one is, first one is x1, second one is x2. That's the number of days we will decide to choose the refinery 1 will be run, and this is the number of days that the firm decides to choose how many days the refinery 2 should be run. This is the decision variable, which means we will put the number of days here and here. So this is actually our solution that we will be able to find. Now, what is the contribution of x1 to the cost, and what is the contribution of x2 to the cost? So we know that that's this 20,000 for firm 1, for refinery 1, and 25,000 for refinery 2. So the contribution of each of these refineries to the cost is 20,000 and 25,000. Now, what we have done here is that we have created these constraints. So that's why I was saying that you don't really necessarily need to write this here, or you can do the same, but we need to create this thing as well here. So let's just the firm needs to meet these constraints. And these constraints, when the firm needs to meet these constraints, the firm needs to have actual production. So what would be the actual production? The actual production, I have written this formula here. If the firm meets these constraints, so I'll do it here so that you see this. There is a formula that I have written here. So if the firm would need, for example, these constraints, that means that it will run x1 for some days, and each of them would cost 400. Each day x1 is run, the firm 1 is run, refinery 1 is run, it would cost 400, and each day refinery 2 is run, it would cost 300, and it should be able to produce this much. Now, the only thing we did here is that we said it's 400 multiply by x1. Now, before we said x1, this x1. However, now we have a decision, which means this is x1, right? So this x1, which will be the optimal. So if we choose this one, plus 300 is the cost of 300 is the number of barrels that the refinery 2 can produce, multiply by how many days will we optimally run this one. So we will optimally run this for x2, the green area days. Now we still don't know the solution, this one, but once we know that, we should be able to then have an actual production. So in a way, this is the constraint and this is the actual production, because actually we will choose this optimal number of x1 and x2 days, and we will run x1 for these days and they produce 400 per day, and x2 for these days and they run 300 of high grade oil per day. Then the actual production should be this. So that's why I have this. Simply you can have another one, which means that we run that refinery 1 can produce 300 barrels of medium quality oil. So this one, multiply this by x1. This is the x1 that we will choose at some point. Sorry, and then click plus. $400 multiply by x2. So the same way we do this, and now we will have the same thing for actual production of x3. Now that would be 200 multiply by the optimal number of days of x1 plus 500 multiply by the actual number of optimal number of x2. So very good, we have these now. Now why did we do that? There is a small extremely important thing. We say that once we choose these x1 and x2, the actual production must be greater than or equal to this. So this is a constraint that we created again, that we should choose x1 and x2 such that the actual production that we will have from that must be at least equal to this. Right? So now let's go to the solution. What we should do is that we should put here, this would be the minimized cost. So we applied a minimized cost formula. So how would be the minimized cost? That's very simple. We found the optimal number of days of x1 and x2, and each day it cost us this much. So that's why we have this would be I'll do it here again. This should be equal to what is the optimal number of days that we choose for x1 multiply by how much does it cost each day, 2000. That's simply like this equation of cost. But this would be minimized cost, because these green areas of x1 and x2 we have chosen, they are the most optimal. So x2 multiply by 25,000. So this is the same thing that I have created here, right? So now what we need to do is to click on this final optimized or minimized cost and go to data, click on the solver here, and once you click on solver, now obviously this solver system remembers your answers. So I'll remove this, I will remove these constraints, and I will remove this. So once the good thing, you can call it, of Microsoft Excel and the solver program is that it remembers your previous calculations. So what you need to do is to set the objective, right? So click this objective. Our objective is this. We want to minimize the cost. right? So it's the minimization of cost. We simply click this number, right? And once you do that, you have option. You want to minimize or maximize. So is this problem maximization problem or minimization? We know that this is a minimization problem. And by changing variable cells, we know that our control variables are x1 and x2. We want the system to change these somehow into different combinations, or play with different combinations and find the one for us that would minimize our this part. Now we need to add some constraints. First constraint is we want this 25 to be less than or equal to the actual production, or in other words, we want to say that the actual production must be more than this 25,000 at least. Add another one, we say that the actual production of the medium one must be at least equal to 27,000, and we add another one and we say that the actual production of low quality oil must be at least equal to 30,000, and we have added all three constraints. Now simply click solve and click OK, and now we have this answer, which is 25 days of x1 and 50 days of x2, and the minimized cost would be $1.75 million. And if you look at our graphical solution here, this was exactly the same. 25 days and 50 days was the optimal solution, and we had the 1.75 million was the cost. So thank you very much for this. Go through the video again and try to solve some other problems, similar problems, and this should, I hope this should help understand this problem. Thank you.